with the flat edge. If that becomes rounded, it's not going to be the same blade. So blade condition is very important. Different types of screens, perforated plates to achieve the finer particle size. And a couple of things about aperture and RPM. First of all, if I have a given RPM, that creates a trajectory through the screen. So if I have an opening in the screen, say I have this 20 mesh screen, and I have a certain RPM, I'm going to get a particular given particle size. If I increase the RPM and change the trajectory, I'm going to make a smaller particle. I'm not just increasing output, because the trajectory flattens out and I end up with a much smaller particle size. Really important thing to think about when you're establishing feed rates and machine speeds, is you need to note what speed you're at. The other thing that really drives this point across is different gauge screens. So if I have the given trajectory, I have established my speed, but I go to a different supplier for a screen or a different type of screen, and I have a thicker opening, I'm going to end up with a smaller particle size. One of the things that we see a lot is when we go to a company, they'll have a reserve of screens, and they'll be all marked 30 mesh or 18 mesh or whatever. And we start micing them and see different thickness screens, quite a bit different. You don't even have to measure them, you can see it. And they're not really, those screens aren't numbered a lot of times, and if you don't number those screens, then you can't relate if something happens to that screen to the product. Are you required to do something like that? Mm-hmm. Yeah. Yep. Okay, so product addition becomes a huge thing as well. Feed rates I've already established. So typically, most machines in our business, the Fitz mill is a pan-fed unit, looks just like this. It's up to the operator to feed product in, scoop it in with that pan feed, or we use an auger feed delivery. An auger feed gives you better feed control. There's a number of different types of feed throats. That is, you can have an overhead feed, you can use vacuum or use process to drive product into the mill, you can use an auger to bring product in. So there's a lot of different ways to feed product in. It's just important to know that if we don't control feed rate, we can end up with a problem. The systems, as we talked about with granulators and other equipment, this type of technology is available with product containment as well. And for those of you that are antiques like me, one common mill in the industry used to be a tornado mill. The same guy that developed the Fitz mill built a tornado mill. He took the blades and turned them this way. Had a 360-degree screen, and actually it's quite a good mill. It was made by a different company, not marketed the same. You don't see as many around, but it actually does an equivalent job. It's a very good design. There's a big caution here. This is really important, that any time with machines with three-phase power means the phases can be crossed if the machine's moved. That is, that means that any machine you have to check rotation. That if I took that tablet press and went over and plugged it in at one outlet, just because it's set up for that machine, if I go plug it in someplace else, it might run backwards. So we always have to check rotation. Now, tablet presses are pretty well dedicated to a particular area or rooms, but mills aren't. And a lot of times people move mills, they create a room here, they plug it in, and the mill starts running the other way, and you can't tell. Unless you look for rotation, you can't tell the difference until you start putting product in and it starts coming back at you. And it doesn't mill the same way. And it sounds funny, but a lot of companies make this mistake. They're trying to force product into the mill when it's running backwards, and they can't figure out what the problem is. So that's a safety issue as well as a operational issue.
One of the issues is what we see in most of the companies. You got cleaning SOPs and you got cleaning documentation. And usually you have all the documentation for the mill itself. So if I'm an auditor, I'm the other guy from the agency, show me your cleaning documentation. You can show them what you did to clean the mill. And that's why the question came before, is it required to number your screens? Usually you got multiple screens the same mesh size, but they're not numbered. So you can run into the situation that the FDA is going to tell you have no proof of ever cleaned a screen in this mill because it's not numbered, it's not tracked. I don't know which screen you use for the product, and you can come in a real big predicament there.
Huge.
Huge, because you mill a lot, that means you have a lot which is not good anymore because you can't prove that the screen in the mill was cleaned.
Yeah.
So I always recommend you get multiple screens, you have to have a logbook for the screen itself where you can say, yes, this screen has been cleaned and it's been used in the mill number 15. A lot of companies don't have it, so be careful with that.
Very good. Thank you.
Question on Clone screens.
Yeah.
How do you know when they're worn out, or what's the best practice for understanding when they're end of their life?
Oh, the question is, how do you know when a screen is worn out? Not necessarily just a co-mill, but any screen, right? I mean, a lot of the different surface. First of all, I use the word screen pretty loosely. There are perforated plates and there are screens. A screen indicates a mesh size. But typically when we talk about using screens on a mill, that it becomes a generic term. So if I say, grab me a 18 mesh screen, or your batch record says I'm using a particular mesh size, it may be a screen or a perforated plate. Okay, so a lot of people don't differentiate. That's important. So this is an excellent question. So the question really is, how do I know when those screens are worn out? Well, a lot of fine screens break. One time we were at a facility and the screen broke and they passed the product back through a metal detector, found metal. They passed the product back through the metal detector, found metal. They passed it back through the metal detector 2 more times, didn't find any metal. And then the decision was made to scrap the material. Didn't agree with it. They approved that they found it all, but somebody said you have to reconstruct the screen, and that would be next to impossible. That's not true. But everybody reacts differently. So if you break a screen, that's very obvious. But then if you break a screen, there are steps to take place. If we're in a perforated plate where it breaks